Hello everyone. In this section, what we're going to do is we're going to continue on with integer problems. Previously, we've looked at number one, a situation where there was very little different from what we've done in the past. With total integers, all we've done is restrict our final decision to whole numbers. And the reason for that is in the real world, we don't often have a scenario where we can hire 2.46 people. We can hire 2 people or 3 people. But if the decision is 2.46, that doesn't have much bearing on reality. After we looked at total integers, we looked at 0-1 integer examples. And 0-1 integer examples were decision, no decision examples. We used linear programming to help us choose if we were going to do something or not, if something was the right choice or not. In this next section, we're going to look at mixed integer examples. A mixed integer example is a combination of both total integer models, total integer and 0-1 integer. So we have both whole numbers and 0-1 results telling us if something was the correct choice or not. That's what we're going to look at in this section. Hopefully, you've reviewed the information presented previously, because everything we covered in total integer examples and everything we covered in 0-1 integer examples are relevant in this situation. So let's begin. Quickly, we'll review the question. Nancy Smith has $250,000 to invest in 3 alternative investments: condominiums, land, and municipal bonds. She wants to invest in the alternatives that will result in the greatest return on investment after year 1. Each condominium costs $50,000 and will return a profit of $9,000 if sold at the end of 1 year. Each acre of land costs $12,000 and will return a profit of $1,500 at the end of year 1. And each municipal bond costs $8,000 and will result in a return of $1,000 if sold at the end of year 1. Additionally, there are only 4 condominiums, 15 acres of land, and 20 municipal bonds available for purchase. So if we look at the base numbers, we see condominiums are $50,000 and they generate $9,000 in profit. Comparing that to the other 2, acres of land are $12,000 and return a profit of $1,500. If we multiply 12 by 4, it's almost $50,000. And if we multiply 1,500 by 4, it's $6,000. So we see condominium is probably the best choice right now. Let's go one more. Municipal bonds are $8,000. If we multiply that by 6, it's $48,000, almost $50,000. If we multiply 1,000 by 6, we also have a return of $6,000. So these, the second 2 investments we see, land and municipal bonds, are both approximately a return of $6,000. The first one, condominiums, is a return of $9,000. In that scenario, it seems very clear that condominiums are the best choice. But we do have additional constraints. There are only 4 condominiums, 15 acres of land, and 20 municipal bonds. This is clearly too difficult to figure out by trial and error. So we're going to do what we always do, and we're going to look at linear programming. So let's review our question and highlight the key information. Nancy Smith has $250,000 to invest in 3 alternative investments. So here we know right away that we have how many decision variables? 3. X1 equals condominiums. X2 equals land. X3 equals municipal bonds. These are our 3 decision variables. This is where we're going to be choosing between what are the correct choices between these decision variables. We're not yet able to put together our objective function. We're not yet able to put together our constraints, but we're getting there. We want to invest in the alternatives that will result in the greatest return on investment after year 1. That means we have a maximization problem because we're trying to maximize return on investment. That's what we've seen so far. So we'll highlight that as well. Next, let's continue reading. Each condominium costs $50,000. And will return a profit of $9,000. Each acre of land costs $12,000 and will return a profit of $1,500 at the end of year 1. Each municipal bond costs $8,000 and will result in a return of $1,000 if sold at the end of 1 year. So what we've found here is more key information. Let's continue reading. Additionally, there are only 4 condominiums, 15 acres of land, and 20 municipal bonds available for purchase. That's our last key point. So now that we've highlighted all the key information, it hasn't been totally clear yet, but we have the key information to A, put together our objective functions, and B, highlight our constraints. So let's do that now. Our objective function, let's highlight that, is we're trying to maximize Z, where Z is return on investment, is equal to, and here we have 9,000 X1. And we see that here. We're trying to maximize return on investment. So it's 9,000 times however many condominiums we buy, plus 1,500 X2, which, as we can see here, is 1,500 times the number of land acres we purchase. Finally, we have 1,000 X3, which is our return on investment, times the number of municipal bonds we choose. So this is our objective function. It highlights the return on investment we can expect depending on how much of each product we decide to purchase. Hopefully, this is clear. Let's move on. After we've created our objective function, we now need to know our, very simply, constraints. So let's highlight that here. So constraint number one, we look up here and we see the very first thing, 250,000. Can we invest more than 250,000? No, it's absolutely impossible. That's the money Nancy has to return, has to invest. We cannot invest more than that. That is a constraint that governs our behavior. So we go down here, C1, and we see that 50,000 X1, which is 50,000 times the number of condominiums we buy, plus 12,000 X2, which is $12,000 times the amount of land we purchase, plus 8,000 X3, which is 8,000 times the amount of municipal bonds that we purchase, must be less than or equal to 250,000. That's our first constraint. No matter how much land, how many condominiums, how much land, and how many municipal bonds we buy, it must be less than or equal to 250,000. Our second constraint, we see here, we've talked about this, we've covered this, we're now down to our three key pieces of information at the bottom. So in this situation, X1 represents condominiums. X1 must be less than or equal to 4. We cannot buy, the number of condominiums we buy cannot be more than 4. The next one, X2 must be less than or equal to, let's go up here, and we see 15. Now, in this situation, that indicates, X2, this indicates that we have only 15 acres of land available. The reason is that was stated in the question. We do it one more time. Oh, my mistake. C4 X3 must be less than or equal to, let's go up, 20. And that states that in this scenario, we cannot purchase more than 20 municipal bonds. So we've covered all of the key information so far. There are two additional things that we have to talk about. There are two additional things that we have to talk about. The first is, we're going to come down here, we've actually got another constraint. And it states that x2 must be greater than or equal to 0. Meaning, we cannot purchase negative land. This will be important in 1 second. C6, x1 must be greater than or equal to 0. We cannot purchase negative condominiums, and integer. Now what that means, if we look at C5 and C6, we cannot purchase a percentage of a condominium. That's what it says here, integer. But we can purchase percentages of land. Land is dividable, divisible. Because land is divisible, we can purchase percentages of it, and we do not have to purchase whole numbers. We can purchase parts of. C7, we repeat that one more time. X3 must be greater than or equal to 0 and integer. That again states that we cannot purchase percentages of municipal bonds. We have to purchase whole municipal bonds. But in general, it is possible to purchase whole numbers, and it must be greater than or equal to 0. We cannot purchase minus municipal bonds. These become important because we're mixing and matching 0, 1, real numbers, and integer values. So looking at our situation, we've completed section 1. We have all of our situation completed. We have all of our constraints listed. We also have our objective function listed. So we move on to the next step. I'll see you there momentarily. Hello everyone. In this follow-up section, we've already, as you can see here on the side, we've already analyzed our question and we've successfully converted the natural language problem into the linear programming format we require to engage the powers of management science software. That's what we've done so far. Now, what we're going to do next is we're going to see together that once these formulas have been put together, inputting them into QM, solving the actual problem is not particularly difficult. Once we've found the initial formula, plugging it into QM is something that almost anyone should have very little problem doing once you get used to the new format a little bit. So, as always, when we begin, we click on Module. We go down to not linear programming like we've done in the past, but integer and mixed integer programming. We click on this, we open or we launch a new file. We're going to title it our mixed integer example. And then we're going to, for constraints and variables, we're going to go back to our question that we had over here, and we see that there are 3 decision variables. We see that we have 1, 2, 3, 4, 5, 6, 7 constraints. All right. And again, we're trying to maximize our return on investment. So we click on maximize and we hit OK. Now, as always, we're going to label our chart effectively. so that we're able to see clearly what we're doing while we're importing the relevant values. We're just going to resize our chart here to make sure everything can be seen. Our first constraint, if we go over here, we see condominiums. Our second constraint, X2, land. It's land by acre. Finally, X3, municipal bonds. All right, we've completed, or we know now, our three decision variables are condominiums, land, municipal bonds. Now the next thing we have to do is we have to label our constraints. The first one, constraint number 1, budget. The second one, available condominiums. Our third, available, in this situation, land, available, here again, municipal bonds. We'll make that a little bit bigger. We'll make this over here a little bit smaller. Okay. Minimize this again. And this isn't overly important. It's just for viewing simplicity. Our fifth constraint, X2 must be greater than or equal to 0. So we can just say, call this X2, land constraint. Condominium constraint. Municipal bond constraint. Now, let's go over to condominiums. How are we going to set up condominiums? In this situation, we're going to enter our return on investment first so we can set up our objective function. So here we go. Condominiums, we have a $9,000 return. Land, we have a $1,500 return. And municipal bonds, we have a $1,000 return. Very simply. Okay, next, budget. This is the first of our constraints. So we have to enter this appropriately. Budget in this situation, we know it's $50,000 to buy a condominium. We know it's $12,000 to buy land. And it's $8,000 to buy a municipal bond. We're probably going to have to make this a little bit bigger. We know this must be less than or equal to the $300,000 that we have available to purchase. That's our first constraint. Our second, available condominiums. X1 must be less than or equal to 4. So 1, which is the count of every time we invest in a condominium, must be less than or equal to 4. Available land in this situation, X2, and again the count, must be less than or equal to the 15 that are available. And finally, x3, we have a situation here where it's 1 must be less than or equal to 20. All we've done in these three constraints is list where maximums are reached. Here, these are quite simple as well. Land constraint, x2 must be greater than or equal to 0. That doesn't really mean anything. It can be 0, it can be more than 0. It just can't be minus. And that's pretty self-explanatory. Again here, condominium, 1 greater than or equal to 0. And again, municipal bond, 1 greater than or equal to 0. What we do now, we've entered all of the relevant data so far. Our final step is, and it's when we come back over here and we see x1, constraint number 6, x1 is greater than or equal to 0, and integer. So x1 is integer. x2 is greater than or equal to 0, but integer is not important. We can buy fractions of land. So what we do here is we change this to real. And x2 or x3 in constraint number 7 must be greater than or equal to 0, and it must be integer. So that's what we see here. That in this scenario, we have integer because it must be a whole number, real because subdivisions are possible, and real number over here because it's integer and we cannot buy percentages of municipal bonds. So that information's been solved. What we're going to do next is we're going to hit solve, and let's check our answer. We see in this situation, our ideal scenario is 4 condominiums and 8.33 acres of land. This gives us a situation where we have $48,500 return on investment, and we have 0 municipal bonds purchased. This is a mixed integer example. Hopefully everyone's followed along, and we'll come back momentarily by running through this very quickly in Microsoft Excel to show you it's possible there as well. Thank you everyone for watching. We'll see you in 1 minute. Hello everyone. In this final section, we're going to solve the problem that we've already solved in QM, but this time we're going to solve it in Microsoft Excel. And the reason for that is quite simply to show you how these problems can also be solved in Excel. It doesn't have to be only QM. So let's get started. We're going to go relatively quickly because, as I said, we've already solved this. So let's expand our windows just to make things a little easier to see. We're going to call it the Nancy Smith investment example. As always, the first thing we put down here is our objective function, essentially. So it's our decision variables. We have 3 choices, as we saw before. Condominiums, land, and bonds. here, return on investment. And this is where we list our objective function. The first one, very simply, $9,000. Land is $1,500. And bonds are $1,000. After we do that, we're going to list our constraints. But we're going to do this, well, for now, we'll say constraint. And we saw over here that we have not one, but 7 constraints. We're going to make this a little easier. Our first constraint is budget. And here, condominiums cost $50,000, land, $12,000, bonds, $8,000. And this must be less than or equal to, less than or equal to and in this case, our theoretical value was $300,000. That's how much he has to invest. Next, over here, we're going to go with equals. We'll leave that for now. Now, as I said, we've listed budget under constraints. Now, we do have one small problem. And that is, that's not a problem. There are multiple ways we can look at this. We're going to do this very simply. We're going to list only budget in our constraint. And I'll show you why in a moment. So here we have condos. Let's call it investment. Let's add a title for simplicity's sake. It's condos. It's land, and it's bonds. These are 3 possible investments. And the last one is ROI, or return on investment. So here we are. These will remain empty because this is where the computer will run the numbers. Return on investment is where we have to enter our example. So return on investment is the return from condominiums times the number of condominiums plus the return from land times the amount of land plus the return from bonds times the amount of bonds. Very simply. And over here, we're going to go with the cost per condo times the number of condos plus the cost of land times the amount of land plus the cost of bonds times the amount of bonds. Done. Now, we've done this differently in the past, but I'm going to show you today that there are alternate ways once you know what you're doing. So, all of the relevant data has been entered, except our limitations on how much we can invest in each, and our limitations in terms of integers and real numbers. But thankfully, we can enter that information when we're inputting our constraints manually. So let's go to the data page. We click on data. We go over to solver. First, our set objective, as always, is to maximize our return on investment here. It's a maximization, and we are changing 3 cells: condos, land, and bonds. We're going to make it simplex LP, and this is something that people have struggled with before, but it's very important to make it simplex LP. And then we're going to add in our different constraints. Now this is going to be a little more confusing. So the first one is that B10, if we look down here, x2 must be greater than or equal to 0. In this situation, we're going to ignore that for a second. We're going to come all the way up here, and we're going to say that x1 is less than or equal to 4. So x1 is condos. So that's B9 less than or equal to 4. We add that. Our second one is that B10 must be less than or equal to 20. Oh, sorry. Our third one is that B11 must be less than or equal to 20. Oh, and I made one mistake. B10 must be less than or equal to 15. So now we have 3 different situations where rather than enter it in the spreadsheet, now we've just very simply entered it here. But we have a couple more to add. So let's do that now. Number one, our cell reference. So condos, if we remember, condos here, B9 must be an integer value. We click there, we add that. We also know B9 must be an integer, so we add that. We also know bonds, B11 must be an integer, and we saw that down here. So we hit OK again. So now we have 5 of our different constraints. We're going to ignore constraint number 5 because it's pretty worthless. It doesn't actually do anything. We just put it in for completion's sake. Now we have one final constraint to add. We'll come up here. And our final constraint is that E6 must be less than or equal to G6. We hit OK. And now all of our constraints are now manually entered in. We've solved everything. So we're going to, as always, we're going to hit the solve button. The solver found a solution, all constraints and optimality. A small mistake was made somewhere. Wait, please. All right, everyone. Sorry about that. I just had to check. I made one small mistake when I input it. Oh, we'll hit OK. I made one small mistake when I was inputting this formula. We have B6 times B9, C6 times B10, and then the last one should have been, and it was corrected, and now we're getting the correct answer. So we have 4 condos, 8.33 land, and 48,500 total value. So that completes our replay. We've seen how to do it. The only difference between QM and Excel is in Excel, what we are doing is we're entering the integer values in the solver. In QM, we were doing it in the last column at the bottom, the last row at the bottom. So thank you again for watching. Our lesson is a little shorter today because there is an additional homework problem, and you can check our Kakao group chat for that. Thanks again for watching. I'll see you next week.